Hey everyone, I want to talk you through this two-part problem. We want to be able to pull out $35,000 each year for 20 years when we retire. Right now we have 15 years before we hit retirement. Your account earns 9% interest, so we want to know how much we need to put away each year right now so we can make a goal, so we can reach our goal to pull out $35,000 a year. So this is a two-part. Right now I'm going to kind of draw a timeline if that helps. So this is now, we're going to call this time 0. This is in 15 years when we want to retire. My pencil's being weird. And then for 20 more years, so plus 20, this is when we want to retire. So an additional 20 years, so that's 35 years down the road. So that's kind of what's going on here. And so for part 1, we're going to work backwards. We're going to start by finding how much do we need to have in our account at retirement so that we can pull out 35,000 a year. So these are the things we need for these time value of money problems. We need payment, compounding time, future, present, and the rate. So the rate is easy, that's 9%. The future value means that after our 20 years, there's nothing left. We've used all of it. So our future value is going to be 0. Our present value, what we have at the start of retirement, we need to find. We know that we're going to be retired for 20 years where we're going to use this money. Compounding, I'm going to put a 1 because it's 35,000 a year. So that's annual. If it said a month, then we'd put 12. If it said a quarter, we'd put 4. But right now it says compounding annually, so 1. And we're pulling out 35,000 each year. So 35,000 is our payment. So we want to find the present value. So you're going to put an equals PV, parenthesis. We're going to put in our rate as a decimal. So you're going to take 9 and divide it by 100, which gives you 0.09. If you are compounding more than once, you'll divide by our compounding. So our compounding here is 1, so anything divided by 1 is itself. If it was monthly, you'd divide by 12. Number of periods would be how many years or months are we making these payments. So we have 20 years and we're one payment a year. So it's just 35,000. If it was a monthly payment, would multiply the number of periods times number of years times 12. Sorry, I messed that up. It's just 20 years. Each year for 20 years, we're having a payment. If it was monthly, we'd multiply 20 times 12. Our payment is at 35,000. The future value is 0, and I'm just going to hit enter now. So we need 319,499.10 in our account at the start of retirement. Now we're going to go to part 2 to figure out how much do we need. How much do we need at the end? How much do we need to put away each month? So part 2, our future value here is going to be the present value. Sorry, backwards. Our present value from part 1 is our future value for part 2. So in part 1, we found out how we need $319,000 in our account at the start of retirement. So now we're going to look at, we've got 15 years to earn that much money. So this is how much money we need in 15 years. So that means our time is 15 years. The interest rate is the same. You're just starting saving, so you don't have any money today. And so we want to know how much money do you need to put away each year so that after 15 years at 9% with no money today, we'll have $319,499.10. So I'm going to type in equals payment. Again, the rate is our interest rate divided by 100, so 0.09, and then divide it by our compounding, and we're compounding annually, so once a year. If it's monthly, we would divide by 12. The number of periods here is 15 because it's annual. If it was monthly, we'd do 15 times 12. Our present value is 0. We didn't have any money when we first started saving. And our future value, that's how much we want at the start of retirement. That's $319,499.10. So 319 and hit enter. So if we put away 10,881.78 a year for the next 15 years, then we will have this much money, the 319. And if we have 319, $499.10, then we'll be able to pull out 35,000 a year for 20 years. And all of this is at 9% interest rate. Thank you for watching, and let me know if you have any questions. Have a great day.